Um, okay, all of those things are details about me. You can just go through. And so that's my workplace, and I work here in Liberia. This is going to be part 3 for the introduction of chemistry. So in this class I'll be talking about elements, compounds, and mixtures. So what is an element? An element is a substance that cannot be split into simpler units by an ordinary chemical reaction. You can break them to smaller particles, but you cannot split them to simpler units. I'll explain this very soon. This is because they are made of one type of atoms. The only atom you can find in an element is one kind of atom, the particular atom. For example, oxygen is an element because only oxygen atoms can be found in oxygen. But water is not an element because there are oxygen atoms and hydrogen atoms in water, like you can see there. To the left, all those are elements. To the right, those are what now? Compounds. There's compound of water and compound of carbon dioxide, carbon dioxide. You see on the right side, I have hydrogen and oxygen. The other one I have carbon and oxygen. To the left side, I just have what? Phosphorus, sulfur, and symbols for elements on that side. Alright? So an element is just made of one type of atom. You see here, I'm having a molecule of oxygen, which contains 2 oxygen atoms. Then I have a molecule of neon, which contains one oxygen, one neon atom. Hydrogen, oxygen, chlorine, sodium, gold, carbon, nitrogen. All of these are elements because they are made up of just one kind of atoms. I'm sure you get the gist. Alright? So what is a compound? What is a compound? A compound is a substance that is made of 2 or more elements chemically combined together. 2 or more elements chemically combined together. Obviously, you find more than one atom in what now? In the compound. Here I'm having water, hydrogen and oxygen. Here I'm having aluminum oxide, aluminum and what now? Oxygen found in those compounds, right? Water, common salt, which is sodium chloride, sand, which is silicon dioxide, ammonia, potassium chloride. All of these are what now? Are compounds because they contain more than one kind of atom. You can see the atoms expressly written there. For sodium chloride, it's sodium and chlorine. For sand, it's silicon and oxygen. All of them are compound also because they are chemically combined together. Their atoms are chemically combined together. Hence, compounds, like elements, are pure substances. Because they're chemically combined together, elements are also pure substances, like elements. Compounds are also pure substances, like elements. To reduce the cumbersomeness of writing, atoms of elements are represented by symbols. For symbols, the first letter and any other letter is used for the name of the element. You see all of those are what? They are symbols of different elements. All of them there, you see. The first letter will always be uppercase and the second will be lowercase. For example, if you see manganese is Mn. The first is capital letter M and the smaller letter for what now? For N. Alright? Iron is Fe, you can see there. Now symbols are both written in English language and in what now? In Latin. All these ones you are seeing here, their symbols are written in what? In English. And like I told you, if you are having more than one letter, the first one will be uppercase and the other will be lowercase. Aluminium, Al, first one capital letter, the other one small letter. For Latin, you see, those are examples for Latin. Like sodium is, the Latin name is used, potassium, the Latin name is used, copper, the Latin name is used, and that's in that order, alright? Here I have the periodic table, which contains all the different elements in the arrangement, okay? Formulae. Formulae is the plural of formula. While symbols represent atoms, formulae represent molecules and ions. So here I'm having elements and compounds, and here I'm just having elements. So I can have molecules of elements and compounds, but I can only have atoms of elements because all compounds are made of more than one atom. So you see on this side here I'm having what now? The symbols, the formula for compounds and elements. On this side I'm having symbols of what? Elements. Atoms of elements are represented by symbols, like I said. Molecules of elements are represented by formula. Molecules of compounds are also represented by formula. You can see that on the left hand side. The one on top, they are for elements. The one at the bottom, they are for compounds. It is not possible to have an atom of a compound. If you have any questions as regards this, please just send the questions over to me. Compounds always have more than one atom. So you cannot have an atom of what? Of a compound. You can have an atom of an element, but you cannot have an atom of a compound. Is that alright? Mixtures. What is a mixture? Alright. A mixture is made of two or more constituents that can be separated by a physical method. Unlike compounds that are chemically combined together, mixtures are physically combined together. Mixtures are impure substances because they are physically combined together. Okay? You see, they are a combination of more than one substance. So a mixture is actually not one substance, it's more than one substance. They are physically combined together. So they cannot be represented by what? By chemical formula. You can use the chemical formula for both elements and compounds, but not for mixtures. They are homogeneous. Sometimes they are uniformly combined together, and other times they are what now? They are heterogeneous, meaning that they are not what? Uniformly combined together. Okay, so mixtures can be both homogeneous and heterogeneous. They don't have unique properties. The properties are a sum of the different constituents that makes the mixture up. So it doesn't have a unique property, unlike compounds, which are completely different from their constituents, components. Okay, see examples of homogeneous and heterogeneous compound there. Please take time and go through, right? And take it backwards. These are more examples of homogeneous mixture. You see them there: coffee, wine, air, brass, steel, natural gas, blood. These are examples for heterogeneous on the other side. Okay, differences between mixtures and compounds. Differences between mixtures and compounds. Take your time out. You can pause this and go through them. The constituent can be separated by a physical mix from mixture because they are physically combined together, but that will not happen for